In the last video, I hope you got a good idea of why eliminating the parameter was an important concept to master when dealing with parametric equations. It's very possible that you have two parametric equations that have basically the exact same path, but they follow along that path in a different way. And by eliminating the parameter, you can see that the two actually share the exact same path. So in this video, I'll show you maybe a more specific example of how eliminating the parameter can help us graph parametric equations a little more efficiently. Suppose you have the parametric equation x equals 2 minus 1/2 t and y equals 4 plus t. And we're going to look at this on the restricted interval where t just runs from 0 to 4. So it starts at 0 seconds and it ends at 4 seconds. So to figure out the coordinate where it starts, I simply plug 0 in for x and 0 in for y to give me the point 2, 4. To figure out where it ends, I plug 4 in for x and 4 in for y to give me the point 0, 8. So now I have an idea of where this parametric equation begins and where it ends. And I could just plot those 2 points. So 2, 4 is the starting point, and 0, 8 is the ending point. And now I probably can guess that I should just connect these 2 points with a straight line and arrows moving from the start to the finish. However, I could do a little algebra to confirm that it is indeed a line and that I got everything all in the right place. So in order to do that, what I can do is I can take my equation for x and solve it for t. So if x equals 2 minus half t, then x minus 2 equals negative 1/2 t. Multiplying by negative 2 and distributing gives me t equals negative 2x plus 4. Then what I can do is I can take that equation for t and plug it into my equation for y. So instead of y equals 4 plus t, I have y equals 4 plus negative 2x plus 4, which gives me the equation y equals negative 2x plus 8. And looking at the graph, we can see that, yeah, that's actually what we saw there. Y equals negative 2x plus 8, a slope of negative 2, a y-intercept of 8, but the additional information that is gained from the parametric equation is where it begins and where it ends and what direction it's heading into. Let's take a look at a slightly different example. Suppose this time you have the parametric equation x equals 3 cosine of t and y equals the constant 4. And we'll look at it on the interval where t runs from 0 to 2 pi. So we think about the starting point, and when we plug in 0, 3 times cosine of 0 is 3, so the starting x is 3, and the y, of course, is 4. The ending point, we plug in 2 pi, 3 cosine of 2 pi is also 3, so again we end at 3, 4. And that seems a little confusing, that it starts and it ends in the exact same point. So we start to think about what is this graph? What's happening? Is it just staying in one place or is it moving about? So what we do is we think about the domain and range of the x's and y's as a function of t. In particular, the range of x is it's the same as 3 cosine, so it has a minimum negative 3 and a maximum of 3. And what that means is in between the start and the end, this function stretches all the way out to negative 3 on the x. And of course, the y stays 4, stays constant. So it must bounce over to negative 3, 4, and then bounce back. So this is simply a graph of y equals 4, but as time ranges from 0 to 2 pi, we would see the point trace toward the negative side, toward quadrant 2, until it reaches negative 3, 4, and then it would bounce right back. Let's look at one last example to see how eliminating the parameter can be really helpful with graphing. Let's say we had the parametric equation x equals t squared plus 1 and y equals 1/2 t. And let's look at this on the interval where t runs from negative 2 to positive 2. So to figure out where this graph starts, I can plug negative 2 in for x and I get 5, and I plug negative 2 in for y and I get negative 1. To figure out where it ends, I plug positive 2 in for x and positive 2 in for y, and I'll get 5 and positive 1. So if I look at those on the graph, I can see that it's going to start here and it's going to end right here. But I don't think it's going to be a vertical line here because I don't see x or y staying constant. So now that skill of eliminating the parameter will be really useful. To eliminate the parameter this time, I'm going to start by solving for t in terms of y. And then I'm going to plug that value of t in for t in the x equation to get x equals 4y squared plus 1. So what I see here is I've got a sideways parabola. X equals 4y squared plus 1 is a parabola that's opening up to the right. So I know where it starts, I know where it ends, and I can think about how it gets there through the vertex there at positive 1 on the x because of the plus 1 in the equation. I just put my arrows on and draw my sideways parabola, and that's all there is to it. I hope this video helps you understand how eliminating the parameter can be really useful when graphing parametric equations.